So here we have a tutorial on how to solve optimization problems in calculus. So we have two sides of a triangle which are 6 and 12, and we have to find the sides of the angle theta in radians formed by the sides that will maximize the area of the triangle. So let's start by drawing a diagram of the triangle. So we have triangle with side 6 and 12, and we have this angle that we want to find to maximize. So the area of this triangle, we're not going to use the typical 1/2 base times height because we have to find the height, and we already have an angle and two sides, so we can just use this formula. 1/2 AB sine theta. Right? So A and B are given to us here already. So let's just plug that in. So A equals 6 times 12, that's 72 over 2 sine theta. And then that equals 36 sine theta. Okay, so we have our equation. Now we're ready to take the derivative. So the derivative of A would be, what's the derivative of sine? It would just be cos. So we get 36 cos theta. So that's the derivative. Now we have to set it equal to 0. So 0 equals 36 cos theta. And we solve for cos theta. So it'll still equal 0. So we have to figure out which angle will cos theta equal 0. And then we can use the unit circle to figure out. Cos is x over r. So when is theta equals 0, cos theta? At these 2 points. Because the x is 0 at these 2 points. So we have pi over 2, comma, 3 pi over 2. Those are the two values. Now we want to find which one of these two will maximize. So we take the second derivative of A, which is the derivative of cos is negative sine, so it will just be negative 36 sine theta. And then we plug in one of these two values for theta. So I'll go with pi over 2. So now sine of pi over 2 is just 1. So the answer is negative 36, which means if it's negative, if the second derivative is negative, then the pi over 2 must be a maximum. So we have pi over 2 as the answer. And you're done. Okay, moving on. We have another problem. So basically, a rectangular plot of farmland will be bounded on one side by a river and on the other 3 sides by a single strand of fence with 2100 meters of wire at your disposal. What is the largest area you can enclose And what are the dimensions? Let's draw a diagram. Say we have a river here, and we have our rectangular plot right here, and let's call this L, and this W, and this is W as well. So the perimeter of this rectangle would simply be L plus 2W. We want to find the maximum area, and the area in this case would be L times W. So the perimeter is given to us by the amount of wire, and we have 2100 meters of wire. So in order to derive this, we need to have one variable only. So we're going to solve for L in this one. So 2100 minus 2W equals L. Now that's L. This we will plug in this equation. So check this out. We're not ready to derive yet. We still have to distribute. So this will give us squared, 4W squared. Okay, now we're ready to take the derivative. Here we are. So set this equal to 0. And then you solve for W. So it will be W is that. So we got the width. Now we have to find the length. So all we do is just go back to this equation. Sorry, this one is easier. The length is just 2100 minus 2 times W, which was 2100 over 8. So length equals 2100 minus 4200 over 8. So a length equals, hold on, let me get a calculator. Length would be 1075 meters. Forgot the units. Okay, so you have length and the width. Now you want to find, I also ask you for the maximum area. So the area is just 1575 times the width, which is, whoa. So the area would be 413,437.5 meters squared. And that's it for today. Thank you for watching.